Hello class, let's continue with the second part of the solution to the midterm type A. So this is the next problem. Problem number 2, the one about the Simpsons and Futurama. Okay, so I'm gonna let you read this on your own. Stop the video, read it once again. I'm gonna assume that you already did that part. So let's let's address this problem. Okay, so problem number 2. There are these many people in a convention, and these people like The Simpsons and Futurama and maybe other things, right? Some people like The Simpsons, some only like Futurama, some like both, and some don't like neither of them. And we have this information. After some investigation, you realize all of these things, okay? And that's the whole context of the problem. Now that you know that, I'm gonna ask you a series of questions. How many questions? 7 questions. A through G. Okay. So the first question is this: find the probability that if you choose one person from the set of all attendees at random, find the probability that this person likes The Simpsons. How do I engage this problem? You do it in this way, by making use of a Venn diagram depicting the relationship among all of these people, right? So this is the Venn diagram representing all the people that are all the attendees to this convention, right? And we can draw the following. We can draw a circle depicting all the fans of The Simpsons. We can draw another circle representing all the fans from Futurama. I'm going to write S and F in order to represent that idea. And we can see that these two circles divide this whole rectangle into 4 parts, which is this one, this one, this one, and the one outside. 4 different and non-overlapping areas. This, and this. Okay. Now, let me label. Let me label how many people we have in each of these areas by making use of these variables A, B, C, and D. What is A representing? A is representing the number of people that only likes The Simpsons. B is representing the number of people that like both The Simpsons and Futurama. C, the people that only like Futurama, and D, the people that don't like either of the shows. So what do we know from the start? We know that the sum of these 4 numbers, A plus B plus C plus D, should be equal to 850. Like this. Okay, what else do we know? If we keep on reading these 3 pieces of information, we have that the people that like both shows, which is B, are 20 times as many as those who don't like neither, which is D. So B is 20 times as many as D. And even though the diagram doesn't represent that visually, it makes no difference. If I tell you that this is 20 times larger than D, then so it is. B is 20 times the size of D. That's my second equation. The number of people that like only Futurama, which is C. This is the people that only like Futurama, and that's 100. And the number of people who like at least one show is 820. The number of people who like at least one show. Which are those people? It's the people that lay somewhere in any of the circles. So it's A plus B plus C. All of these people that live inside this area or this area or this area are the people that like at least one show. These ones only like one show, these ones only like one show, and these ones like both shows. So all of these three sections can be set to like at least one show. There you go. With these equations, guys, with these four equations that maybe we can label equation 1, equation 2, equation 3, and equation 4, we can get the the quantities for A, B, C, and D, or we can find the values. We already have one, C equals 100. So let me write that in here. A equals, B equals, C equals, D equals, C equals 100. And now we can make use of equation 1 and equation 4. If I tell you that this is equal to 820, then this is equal to 820, and I can just replace it. So 820 plus D equals 850. So clearly D must be 30. So the second one down. If I know that D is 30, then 20 times 30 gives me B, which is 600. And if I know all that stuff, then I can find A by perhaps using this one again. Okay, I'm gonna have A plus B, which is 600, plus C, which is 100, equals 820, and that gives me A equals 120. That's how you find the values of each of these, of the number of people in each section, by doing some algebra. And then we could just forget about this. Well, I mean, when you work out this type of thing on a paper or something, don't erase it, just leave it there. So this is all we needed, guys. This is the tough part of the problem, finding these four numbers. The rest should be rather easy. For example, finding the answer to A, find the probability that this person, if you choose a person at random from the set of all the attendees, all of them, what is the probability that this person likes The Simpsons? Okay, how many people like The Simpsons? All of these, A plus B. All of these people like The Simpsons. So I need to add these two numbers. 720 over the set of all the attendees, which is 850. That's it, guys. That's it. You don't have to do anything else. B, find the probability of the event B. I'm calling B this event. That this person that you choose at random likes only The Simpsons. That is a very important word. Only The Simpsons, which is just this bit. These people that comprise this half moon, this moon thing, kinda, which is A, that's the people that only likes The Simpsons, which is 120. 120 people only like The Simpsons. Among how many? Among all the attendees, which are 850. C, find the probability of C, which is this person likes South Park. You have no info about this. Some people try to make some very convoluted argument. No, guys, I mean, the problem never tells you, never pinpoints, or never addresses anything about South Park. You cannot make any assumption. Okay, so you cannot answer this question. That's it. I cannot answer. I don't have enough information to answer this question. D. Then we have this one person from the set of all attendees. From the set of all the attendees is chosen at random, and you happen to know that she likes Futurama. So this is a girl that likes Futurama. You know that already. And given that you know that, D, what is the probability that she likes The Simpsons? So let's find that probability. So I already know that the person that I chose at this part of the problem, which is distinct from the first part, I already know that the person that I chose at random likes Futurama. So this person already is within this circle. Okay? So this is your new sample space. All of this, anything and everything outside the circle F completely disappears from your perspective. It's no longer important. So if you know that you picked one person from this circle F, what is the probability that she likes The Simpsons? Okay, which of these two sections correspond to such event? This one, right? Because these people like both shows and these people only like Futurama. So if you want to know what is the probability that she likes The Simpsons, then it's this many favorable outcomes, which is B, which is 600, right? Over all the people that are inside F, which is B plus C. B plus C, 700, because this is your new sample space. You are not allowed to put in here 850 anymore, because this is a conditional probability. And that's it. That's it. Probability of E. What is the same person? You choose somebody at random. You happen to know she likes Futurama. What is the probability that she does not like The Simpsons? Well, it's the other bit. It's this other bit. These people only like Futurama and therefore do not like The Simpsons. So how many favorable outcomes? C, which is 100 among all the possible outcomes, which is all of these people inside the circle, which is 700. That's it. And then two other questions. Now we have this instruction. Two people are chosen at random from the set of all attendees. Two people. What is the probability that they both like The Simpsons? They both like The Simpsons. If you watched the explanation given on a previous video, I told you that when you have this type of question, you have a set of objects or whatever, and you want to calculate the probability of something like this. Okay, like, well, if I choose two at random, if I choose two, what is the probability that in this case they both like The Simpsons? What you have to do is this type of analysis. You're gonna choose two people from the set of 850 attendees. In how many different ways? In how many different ways can you choose two people from by using 850 different people? How many different choices of couples do you have? What you do is you take the number n, this is the number n of total objects, and you basically multiply 850 times one less in this case, because you have two people. You're gonna choose two people. So that's it. This is the number of all possible combinations all possible combinations for a couple by using these many objects. Okay. Now, what is um, what is the chance that both of them like The Simpsons? What you have to do is uh, this other question. Solve this other question. If you know that how many people like The Simpsons, A plus B, which is 720. You know that 720 people from here likes The Simpsons, 720. How many possible combinations can you make with these many Simpsons fans? How many possible combinations of two? Okay, it's the same idea. What you do is you go like this: 720 times 719, and you have these many possible combinations. And this accounts for maybe the Simpson fan number one and the Simpsons. I mean, you have 720 fans of the Simpsons. All of this number, guys, which is a very large number, 720 times 719, this accounts for all the possible combinations. The first fan with the second fan, if they had labels, and the first fan with the third fan, and the 100th fan with the 719 fan, and so on. All these possible combinations are already being accounted by for this with this quantity. So these are all the possible combinations of two people that like the Simpsons that you can get out of this many people, and these are all the possible combinations that you can make out of these many people. So how do you solve this question? What is the probability they both like the Simpsons? Well, just account or just make the ratio of all the possible combinations of two people that like the Simpsons. You can take out of all the possible combinations of two people that you can get out of the whole set, which is this. So that's it. The solution is going to be 720 times 719 over 850 times 849. And that's it. You don't have to do anything else. It stays like this, and it's okay. And what is the probability they both don't like either show? They both don't like either show. Well, that's this set, right? This is the people that do not like either show. How many people do we have? 30. 30. So you do the same thing. You do the same thing. What you do is this. Calculate the number of possible combinations you can get of people that don't like either show, which is all the people in D, in the section D. You have 30 people, so all the possible combinations is 30 times 29. This many. This many combinations of couples you have that don't like either show. So the probability of G is just as before, all the favorable cases over all the possible cases, like this. And that resolves this problem. That's problem number 2 from section B. Okay, and just to finish off, the next problem is technically the problem 3 and 4, but everybody solved these two correctly, so I'm not gonna go there. There is no point. 3 and 4 are quite simple. Problem number 5, though, let me address this one. You have a given data set of n values, x1 through xn. You have n values, and they're given as variables. You don't know what each value is. The mode, the mean, and the median of this data set are these three. The mode is represented by this symbol. The mean, as we know, is represented by this symbol. And the median is empty. That's it, guys. That's all. I mean, there are no values involved in here, no constants. It's all given in terms of variables. Next, a new dataset is created by adding a constant c to each of the values in the first dataset. So this is my first dataset. I'm gonna call it S, and I'm gonna call the new dataset Sn. I'm gonna call it, well, I'm gonna call Sn the new dataset. And now this new dataset is gonna be this one: x1 plus c, x2 plus c, up until xn plus c. This is the old dataset, this is the new dataset. That's the whole context. Question A and B. Find the mode of this new dataset. Find the mode. Okay. What is the mode? What is mode? It's the number that repeats the most, right? Among these many, which is this one. Okay. Now you must agree, guys, that whatever the mode, like we don't know which of these values is the mode. Let's just suppose it's x2. Let's suppose it's x2. So it's gonna be the corresponding in the other set, right? This is gonna be also the mode, because every single value will increase by the same amount, right? And therefore the mode will be the same, just plus c. There is not a there isn't any big argument to be holding here. I'm sorry. So the new mode, which I can represent by this mode new, is gonna be equal to the mode plus c. Okay, because every single value in here gets increased by c, by this constant c. So the new mode is gonna be the old one plus c. There isn't any real argument to be had here, not much. This is the difficult one. Suppose x n, x bar n is the mean of the new dataset. Demonstrate by using the proper definition of the mean, which is this. As you may remember, the definition of the mean is the sum of all the values x divided by the number of values. And I want you to demonstrate this, that this is true, by using this formula, the definition of the mean. How do you do this? Okay, let's do it. I'm gonna do that in white to make a difference. Okay, just take a look at your new data set. This is your new data set. x1 plus c, comma, x2 plus c, comma, etc. up until xn plus c. If you want to calculate the mean of this data set, what you do is this. You write the mean of this new data set will be equal to the sum of all its values, this plus this plus this plus this plus this, over the number of values, which is n. Now let's replace this. What is the sum of all the values? Well, it's going to be x1 plus c, that's the first value in the data set, plus the second value, plus etc. up until the very last one, over the number of values that we have, which is also n. Okay, so now look at this expression, and I'm gonna separate, since this is addition after addition, you know, something plus something plus something plus something. I can drop the parentheses, and I can collect all the values x1, x2, x3, xn, etc. on the left, like so. I can do this. I'm just collecting them or rearranging them, and all the values c on here on the right, like this, over n. And then just realize that how many c's we have in here in this whole term, in between parentheses, how many c's? We have n c's, right? We have one c, two c's, etc., and n c's. So all of this is equal to nc, clearly, right? Plus all of this is nc over n. And then finally, I can separate this division. I have this big term plus this other term here being divided over n. I can separate this division, this addition. Yeah, I can separate this division into this. I'm gonna have to proceed over here. I can separate as this x1 plus x2 plus blah 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 plus xn over n plus nc over n. That's all I'm doing. I'm separating this division into two little bits, just as you would do in this. 2 plus 4 over 2, that's the same as 2 over 2 plus 4 over 2. It's the same. And then we're basically done, because now you can see that this, the sum of all these values over n, this is actually the mean of the previous data set, because it's the sum of all the values over the number of values. So by definition, that's the mean of the previous data set. And this expression resolves into C after you cancel n and n. And that's it. This is my conclusion. My conclusion is that the new mean for the new data set is going to be equal to the old mean plus the constant we just added, which is what you have it here. Okay, and that's it, guys. This concludes the process of the solution of this exam. Thank you very much.